So this question's about the acceleration of a block down a frictionless ramp. So I'll just give a little diagram what's going on here. So here's a ramp. It says the angle is 30 degrees, and there's a box on it, and there's no friction, there's no applied force. It's just gravity and normal. That's all there is. So this block is going to accelerate down the ramp. So if I go with the free body diagram, that's just going to be this box again, but I'm not going to draw the ramp. I will draw gravity, and I will draw the normal force, and I will draw the normal force such that it is approximately equal to the y component of gravity. I should define my x and y components. I'll do that at the top left here. I'll say my x component is parallel to the ramp, down the ramp. And I'll say my y component is the same direction as the normal force. That's generally a good strategy to use. So in this free body diagram, the normal force equals to the y component of gravity. They cancel each other out, and the net force will just end up equaling the x component of gravity. So symbolically, I'm saying that the normal force magnitude is equal to the y component of gravity. Okay, and they're balanced. But my net force is going to be the x component of gravity. That's just what's left over. It's in the x direction. So then to calculate the acceleration here, I would change F net to ma, which is Newton's second law. And the x component of gravity is mg times sine of theta. In the x direction. Okay, you will notice that if you divide both sides by m, the m's cancel out, which is a good thing because we were not even given the mass of this block in the first place. So the acceleration is just going to equal to g times sine theta. So that would be 9.8 times sine of 30 degrees. It'll be in the x direction. And 30 degrees is a special angle. Sine of 30 is equal to a half. So 9.8 times a half is 4.9 meters per second squared in the x direction. All right, so that is the acceleration of a frictionless ramp. Actually, if I go back a couple of steps, this is always going to be the acceleration of a frictionless ramp. I'll just write at the bottom here. Acceleration is always going to be g sine theta for a frictionless ramp with no applied forces, no any other forces. It's just gravity and normal force.